Most transformer failures don't happen suddenly. They build up quietly over weeks, months, sometimes year, until one day the transformer announces it's done. And then the catastrophic failure occurs. And we are not talking about any other device. We are talking about the most expensive device in the whole substation. And if you have ever been on site when the transformer trips, you know the feeling. One minute everything is normal, next minute you are starting at looking at the alarms, protection flags, and shutdown that can cost lakhs or crores per hour. So in this video, I'll break down the 5 major reasons why transformer fail, and these reasons are also on top of the list of the organizations like the IEEE, CGRE, and different transmission and distribution utilities. And I'm not going to keep it theoretical. This is aligned with the real world failure database and reliability surveys from the industry. Let's start with the biggest truth in transformer life. A transformer is basically an insulation system with a lot of copper in it and also steel. So your solid insulation is paper or pressboard. Then we have liquid insulation, which can have oil or ester. And once insulation strength drops, failure becomes a matter of when, not if. Now the question is how this insulation actually degrades. Insulation deterioration accelerates mainly due to heat caused by overloading, maybe the moisture from aging paper, leaks, poor drying, breathing issues. Then we have oxidation due to sludge formation or acidic oil, or even due to particles, maybe contaminations, which can include conductive debris, carbon and metal particles. Over time, paper degree of polymerization falls, oil acidity rises, interfacial tension drops, and dielectric strength gets weaker. That's when partial discharge, arcing, or winding to ground fault becomes more likely. Now, if you're interested in knowing what partial discharge is, then check out my video on that. You will get link for it down in the description. Now, there are some signs that may indicate the insulation of the transformer is under stress or not in good condition, like rising moisturizer in oil, oil quality degrades, hotspot alarms, and repeated overload history. Now, insulation failure is rarely a bad luck. It's usually missed condition monitoring or ignored trends. And industry failure analysis work shows that the failure often traces back to insulation stress accumulating over time, and that many transformer units are removed only when the risk becomes clearly unsafe, and by that time it's already too late. Now the second big cause, winding failures. Winding failures can be turn-to-turn short, phase-to-phase fault, or winding to ground fault. And what makes it dangerous is once it starts, it escalates violently because fault energy inside a transformer is massive. Now, why winding fail in real life? Well, there are two common root paths. One, the insulation weakness, which we already talked about in the reason one. Second could be the mechanical damage, often triggered by fault forces. Now, during an external short circuit fault, current shoots up. That creates huge electromagnetic forces that try to physically move the winding. If the bracing is weak, aged, or loosened over time, you can get winding deformation. And winding deformation eventually becomes insulation failure. In a large failure database compiled from utilities, winding or short-edge turn shows up as one of the most common reported failure causes. If there is something wrong with the winding, you will generally have signs like differential protection operation, a sudden gas relay events, a DGA spike, unexpected impedance changes, or abnormal excitation current. Now, before we go to the next cause, if you enjoy easy to understand content on substation, switchgear, power system, do consider subscribing to the channel. On this channel, you will already find a lot of industry relevant content. So thank you in advance for subscribing. Now let's go to the third reason. If there is one component that fails in a way that looks sudden and dramatic, it's the bushing. A bushing is not just a terminal. It's a carefully designed insulation system which is exposed to weather, contamination, thermal cycling, switching surges, and high electrical stress. So, why bushing fails? The common mechanism includes, moisture ingrays, partial discharge inside the bushing insulation, oil leaks if it's oil type bushing, overheating at connection point, which is the result of loose clamps, poor contact pressure, or the contamination leading to tracking and flashover. And large utility failure dataset shows bushing related failure as the leading reported cause in some populations and manufacturing decades, sometimes even dominating compared to the winding faults. And here are some of the signs that may indicate that something is wrong with the bushing. High tan delta or capacitance change trading. IR camera shows hotspots at the terminal. There is audible noise, visible tracking or puncture signs, and maybe sudden catastrophic failure with tank rupture. Fire is can be the risk in the worst case as well. On-load tap changers, as the name suggests, used to change the transformer tap when the load is live. Transformer tap changing is one of the important methods used to control the power system voltage. And if you're interested in knowing more about power system voltage control methods, you can check out my full playlist on that. You'll get link for it down in the description. The transformer tap changer is basically a controlled switching device that operates repeatedly under load. That means arcing is part of its normal life, and anything involving repeated arcing will eventually wear out. So why OLTC failure happens? Here are some of the reasons. Contact erosion and increased resistance, carbonization and oil contamination in the diverter switch, poor timing, misalignment or mechanical wear. It could also be the result of inadequate maintenance or wrong oil management. And these are some of the reasons why the OLTC may fail. In large failure causes breakdown, OLTC failure appears among the leading categories after the winding and bushing causes. Now, if something is wrong with the on-load tap changer, you will see signs like voltage regulation issues and abnormal tap position behavior, mechanical irregularities. You will see, excessive temperature rise in tap selector path. Now, OLTC is one of the critical devices to keep an eye on. In case of any issue, it may lead to transformer failure directly. Next is thermal overload and cooling system failure. This is one of the extremely common and extremely underestimated cooling failure. Many transformer failure starts as simple story. A fan bank doesn't start, a pump trips, a radiator valve is stuck, filters are clogged, and the transformer continues running, just hotter day after day. Heat accelerates insulation aging massively. Even if you don't remember the exact number, the practical takeaway is simple. Hotter transformer is equals to exponential faster aging. Here are typical real-world triggers of thermal overload. Failed pumps or fans not alarming correctly, wrong control setting for cooling stages, radiator choking due to dust, poor ventilation or installation constraint, overloading beyond nameplate without a thermal assessment, loss of oil circulation due to the blockage or low oil level. In reported failure records, overload and cooling loss often shows up inside the other bucket of causes because they are not always recorded as the final failure mode, but they frequently drive the transformer toward insulation collapse. So here is the quick summary of the video. We talked about the 5 reasons why a transformer fails. First, insulation failure. Second, winding fault. Third, bushing failures. Fourth, oil failures. And fifth, overheating due to overload and cooling system issues. And these issues are not built suddenly. This happens over weeks, months, or even years. Most catastrophic failures are just the final moment of a long chain. If you track conditions like DGA trends, moisture, bushing tan delta, temperature, OLTC health, you can often catch the failure months earlier and save a lot of things, right? So those were the 5 common problems or 5 reasons why a transformer fails. If this video was helpful, then give it a thumbs up and do share it with the people you think might be interested in knowing. If you want me to make any video related to the transformer topic, then do comment that in the comment section below. Thank you for watching, guys. I'll see you in the next one, but till then, keep watching, keep learning.